Okay, so today we're going to look at 3D vectors. So we're looking at vectors in the plane x, y, and z. So we've looked at 2 dimensions, now we're looking at 3 dimensions. So that means we've got coordinates x, y, and z for our point P. So that means we can look at position vector OP. Okay, and that will have a vector of x, y, and z. So, for example, let's say that P has the coordinates 2, 3, 4, say. That means OP will be the vector 2, 3, 4 in column vector form. Or if we're looking at it in the IJ format, that means it will be 2I plus 3J plus 4K. So K is our X unit vector. Our Z unit vector. Now, when we're looking at this, we can also look at finding the magnitude, so the length of OP. So that will be this distance from the origin to the point P, wherever P may be. And if we have a look down here, I'm going to remind you of some Year 9 work looking at 3D Pythagoras. Okay, so 3D Pythagoras tells us that we need to find this distance here first, so let's call that D. So if we wanted to find distance D, so Pythagoras tells us that D squared equals A squared plus B squared, because we've got this right angled triangle here. But D is the bottom of the other triangle, and so if we square C and D, then we would get the distance OP. But obviously that would be squared too. But remember, D is just A squared plus B squared. So if we place that in, and I'm just going to write it in a different order. So instead of D, we've got D squared, sorry, we've got A squared plus B squared. And then we add on our C squared, and that gives us OP, or the magnitude of OP squared. So that's why it kind of works out that way. So if we want it in a format that we can now use, OP, magnitude of OP, is the square root of A squared plus B squared plus C squared. Now remember, this is because P has the coordinates A, B, C, or OP has the vector A, B, C. So if we go back to our example at the top where OP was 2, 3, 4, and we put it into our formula so that we find the magnitude of OP, that means we get 2 squared plus 3 squared plus 4 squared, which means we get the square root of 4 plus 9 plus 16, which gives us the square root of 29. Okay, so the magnitude of OP is the square root of 29, and there's nothing more we can do with that, so we just leave it as it is. Obviously, if there were some squared numbers, then we would take out the squared numbers or divide out the squared numbers. Okay, now let's have a look at a few properties in terms of our, or operations should I say, in terms of our 3D vectors, and they work in pretty much the same way as they do in 2 dimensions. But we'll remind you of them anyway. So operations in 3 dimensions. So if we have our vector A, which has A1, A2, A3, and our vector B, which is B1, B2, B3. Similar to the 2 dimensions, the vectors are equal. If A1 equals B1, A2 equals B2, and A3 equals B3. And we can also add our vectors. So if we add vector A to vector B, then we end up with A1 plus B1, A2 plus B2, and A3 plus B3. and we could subtract them too. So again, we just subtract the different components from each other. So A1 take away B1, A2 take away B2, and A3 take away B3. And the last thing we learned was just multiplying it by a scalar. So our scalar is k, so we multiply A by k. Then all we have to do is multiply each of our components within our vector A by our k. And that's all our operations that we're going to do with 3 dimensions. Now let's have a look at some properties. And again, these ones fit in the same way they do for 2 dimension, they do for 3. So A plus B is the same as B plus A, so it doesn't matter which way around you add them, you're obviously still going to get the same thing, so it works in the same with vectors. And A plus B plus vector C is the same as if you add your B and C vector first and then add your A. What's going on there? So it doesn't matter what order you add them, you're going to end up with the same thing. And if you have vector A and you add on the 0 vector, then that's the same as the 0 vector add onto the vector A. Either way, it's just vector A. You're just adding nothing onto it. And the magnitude of k, remember k is just some scalar, times that by the vector A. So we're finding the magnitude of this, and this is the absolute value of k, because this is always going to be positive. Think about, you're only square rooting it, so you're going to get your positive answer, because we're looking at magnitude, which is distance, so you don't have a negative answer, is the same as the absolute value of k times the magnitude of A. So you can work it out that way. And then the last property we're going to look at is k, some constant, and scalar, and we're going to multiply it by vector A plus vector B, and that's the same as if we multiply each vector by k first. Okay, so there's your properties of vectors. Now we're going to move on, plowing through the work, solving vector equations. Now these pretty much exactly like equations. There's one slight thing you've got to be careful of, but that's a notation thing. So if we had 2 lots of x, vector x equals vector A, to find our x, we would do a half of vector A. And so the bit that you have to be careful of is you shouldn't write this as A, vector A, divided by 2. It just doesn't quite make sense. You have to stick with your half instead. So that's one. We have a look at something else. So vector x plus vector B, plus vector A equals vector B. So again, if you wanted to get find x, then you would do B minus A. So you're subtracting vector A from both sides. And let's have a look at a couple of examples now. I think most of this you guys will cope pretty well with. But let's say we have vector A, and this is -2, 3, -1. And we want to find the magnitude of 2A. So the first thing we're going to do is find 2A. So 2 lots of our -2, 3, -1 gives us -4, 6, -2. And then we need to find the magnitude. Now remember, we could have found the magnitude of A first and then multiply that by 2. But we can do this way too. So now we're just squaring -4 squared plus 6 squared plus -2 squared. Notice I put them in brackets, otherwise you might end up with your negative signs. Remember, they're going to cancel each other out. So -4 times -4 is 16 plus 36 plus 4 gives us the square root of 56. Okay. And you could, if you wanted to, take out a factor of 4. So if you divide that by 4, you're going to end up with 14. And so we end up with 2 root 14. That's the square root of 4 is 2. And you should get into the habit of doing that really if you can, simplifying it. Okay, let's have another example. So this one we're going to look at a bit more of a wordy sort of style of question. So we're going to find the coordinates of C and D given that A, B, C and D are concurrent and equal distance apart. So I'll have a sketch of and A has the coordinates of -2, -5, 3, and B has the coordinates of -1, -2, 2. So if we kind of have a little sketch of what's going on. So we've got this straight line, and A is here. So that's got coordinates -2, -5, 3. B has coordinates -1, -2, 2. And then we need to find C and D. Okay. So to find C, what we need to do first, I'm going to change pen so we can see what's going on. We're going to find this vector A, B. Okay, so AB vector, remember we were looking at this previously, would be OB take away OA. Okay, so using the coordinates, OB would be -1, -2, 2, and A is -2, -5, 3. So if we subtract them, we get 1 and 3 and then -1. Okay, so that's our vector AB, sorry. Now if we wanted to go to C, we need to do that vector one more time, don't we? So to get AC, we would do OA plus 2 lots of AB. Okay, and that would take us to OC, sorry, no, AC. Okay, so we start off at A, and then we go back to, no, let's start this again, I'm not happy with that. Let's start again. So if we wanted to find AC, we would do OC, take away OA. There we go, that's better. Now AC, we know, is 2 lots of AB, because they're equal distance, they're concurrent, they're along the straight line. So it's 2 lots of it, and we have not done anything to this side. Now what we want to do is we want to find OC, we know everything else. So if we add on OA, we end up with 2AB plus OA gives us our OC. So I've just added both sides on OA. Now this we know, because we know AB is 1, 3, -1, so we're timesing that by 2, and A is -2, -5, 3, and then we can find OC. So 2 lots of that will give us 2, 6, -2. Wouldn't try and do this all at once, do it in a couple of steps, because otherwise you're more likely to make a when you add them, we end up with 0 and 1 and 1 again. So that's our OC. And for OD, we'll find this one. We're going to have, start with our AD equals OD minus OA. And so this time we're going to have 3 lots now of our AB. And again, we want to find OD, so we're going to move our OA to the other side. So 3 lots of AB, add our OA, and then we can fill in what we know. So we know our AB again. So 1, 3, -1, and our OA is -2, -5, 3. So working out 3 lots of our AB plus our OA gives us our OD of 1, 4, 0. Now obviously the question asks for coordinates. So our coordinate of C is 0, 1, 1, and our coordinate of D is 1, 4, 0. Alright, now you guys are ready for exercise 12G.